What is the effective annual rate of interest corresponding to a nominal rate of 6% per annum payable half-yearly? Well, the question asks what will be the rate of interest for the amount that is obtained by calculating it on 6% per annum rate of interest payable half-yearly. So let us first assume that the principal is 100 rupees. The compound interest is payable half-yearly. If that is the case, let us calculate the amount. It is equals to P into 1 plus, as it is payable half-yearly, the rate becomes half upon 100 raised to the time period becomes twice. So let's calculate the amount. The principal is 100 rupees times 1 plus 6 by 2, and that's 3 upon 100 raised to 2. Right, that's 100 into 103 by 100 raised to 2. That's 100 into 103 times, okay, let it be as it is, 103 square upon 100 square. So this square and this 100 gets cancelled out. What we have is 103 square, which is 10,609 upon 100, and that's 106.09, and that's the amount if the interest is paid half-yearly at this rate. Now we want to calculate the rate of interest for this amount if the interest is paid yearly, right? Now for interest compounded yearly, we have amount is equals to P into 1 plus R upon 100 raised to N. Okay, now N is 1 year. The amount is 106.909 is equals to 100 into 1 plus R is what we have to find upon 100 raised to N is 1. So this is 106.09 is equals to 100 plus R. So therefore R is equals to 106.09 minus 100, that's 6.09%. So the rate is option D, 6.09%. A sum of money invested at compound interest amounts to rupees 800 in 3 years and to rupees 840 in 4 years. What is the rate of interest per annum? Well, we know the formula for compound interest, which is A is equals to P into 1 plus R upon 100. In the first case, the amount is 800, so it is equals to the principal amount is we don't know into 1 plus R is what we have to find upon 100 raised to N, and in the first case it is 3 years. So this is equation 1. Now this same principal when invested for 4 years gives you 840 as the amount. So you have 840 is equals to P into 1 plus R upon 100. The rate of interest is same, raised to the number of years is 4, so raised to 4. So this is equation 2. Now we are dividing equation 2 by 1, right? So on the left hand side we have 840 upon 800 is equals to P into 1 plus R upon 100 raised to 4 divided by P into 1 plus R upon 100 raised to 3. So this P and this P gets cancelled out. This 1 plus R upon 100 raised to 3 cancels out 1 plus R upon 100 raised to 3 in this term. So what remains is only 1 plus R upon 100 raised to 1. Okay, so we have 84 by 80 is equals to 1 plus R upon 100. So again 84 by 80 is equals to 100 plus R upon 100. This 0 and this 0 gets cancelled out, and if I divide this by 4, so 4 2s are 8 and 4 1s are 4 and 4 2s are 8. Okay, and 2 times 5 is 10. So I have 21 times 5 is equals to 100 plus R. Therefore R is equals to 21 times 5 is 105 minus this 100. So R is equals to 5%. So option C is the correct answer. What is the least number of complete years in which a sum of money put out at 20% compound interest will be more than double? So the question says that the amount should be more than the double amount invested. So more than twice of P. Well, the formula for amount is P into 1 plus R. The rate is 20%, so 20 by 100 raised to N. And this should be greater than twice P. And we have to find out the value of N, the number of years. So this P and this P gets cancelled out. We have 1 plus 20 by 100, that is 120 by 100 raised to N greater than 2. So this is 1.2 raised to N, which is greater than 2. Now you will have to apply trial and error method. Let us calculate the square of 1.2. So 1.2 raised to 2 is basically 1.44, which is still less than 2. 1.2 raised to 3 is equals to 1.728, which is also less than 2. Again, let us increase the power. 1.2 raised to 4. It is 2.0736, and that is greater than 2. So 1.2 raised to 4 is greater than 2. Therefore, N is equals to 4. Right. So we have our answer, option B. A sum of money is borrowed and paid back in 2 annual installments of rupees 882, each allowing 5% compound interest. What was the sum borrowed? Well, the sum borrowed is the principal, and let that be P. Now, because there are 2 annual installments, we can consider that there are 2 principals. Right, the principal for the first installment and the principal for the second installment. And if we add these 2 principals, we get the original sum that's borrowed. Now we know the formula for principal. Principal is equals to the amount upon 1 plus R upon 100 raised to N. Right, so we have for the first installment the amount is 882. In fact, for both the installments, the amount is 882. So 882 divided by, we have 1 plus the rate of interest is 5%, so 5 upon 100. Now what is N? Well, the first installment is paid after 1 year. So N is 1. That means the compound interest will be levied for only 1 year. So plus, let's talk about the second principal for the second installment, right? So the amount is 882 again, divided by 1 plus, again the rate of interest is 5 by 100 raised to, this will be 2. Why 2? Because the second installment will be paid in the second year. That means after the second year. So a total of 2 years will be the time period for calculating the compound interest, right? So we have 5 times 20 is 100. Here also 5 times 20 is 100. So I have 882 divided by, I have 21 by 20 plus 882 divided by 21 by 20 whole square, and that is equals to 882 times 20 by 21 plus 882 times 20 square, that's 882 times 400 divided by 21 square is 441. Okay, so this is equal to, now 882 by 21 is equals to 42. So this is 42. Again, this is, if I divide 882 by 21, this is 42, and again 21 square is 441, so this is 21, right? So 21 times 2 is 42. So I have 42 times 20, that's 840, plus 2 times 400, that's 800, and that is equal to 1640, 1640. So option B is the correct answer, and that's the sum borrowed, 1640.